Okay, class, we're going to solve more rational equations, but this time we're going to take it a step further and we're going to look at ones that have a domain restriction. So as it says at the top here, the values of x that would make the denominator equal to 0, we must exclude these from the answer. So that's a domain restriction, okay? And when it's equal to 0, it makes our fraction undefined. So from now on, every time we have a fraction, we want to be asking ourselves what's going to make that denominator a 0. Okay, and a common misconception is a lot of times students will think because x is 0, therefore the denominator is 0. That's not necessarily true. X can be any number that makes the entire denominator 0, not just x. Okay, so again, we got to keep our mind open to what numbers are out there. Okay, so we look at example A. This is basically a review from earlier in the week. There is no domain restriction here. So I'm going to go ahead and just write none right away. All right, and how do I know that? Well, if I just look at my denominator here, there's no variable down there. So there's no number x can be. Okay, we just got a 2 and a 3. Those aren't going to just magically change. So no domain restriction here. Okay, so what I'm going to do is kind of review what we did earlier in the week and solve this rational. First things first, we need to find the LCM. So we look at 2 and 3. This common multiple will be a 6. All right, so that means we're going to multiply the whole entire numerator of this this entire fraction, this entire equation by our LCM, which is 6. So I'm going to multiply 6 to there. I'm going to multiply 6 to that numerator, and I'm going to multiply 6 here at the end. So the entire equation. All right, and then I'm going to simplify, and this is going to get rid of our denominator. So the whole point of solving rationals is to get rid of denominators. So 2 goes into 6 3 times. 3 goes into 6 twice. And then nothing goes into the other one. So let's rewrite this problem. We're going to get 3x plus 2 times 2 would be 4x. And then 5 times 6 would be 30. All right, so pretty easy. Combine like terms, we get 7x. And then equals 30. Divide the 7x both sides. Let's cancel out. And we're going to get x equals 30 over 7. All right, so that'll be our answer to the example A. Okay, if we look at example B, okay, very similar to A, except a pretty simple equation, but we do have some denominators here. All right, so just ask yourself, looking at that 5 over x, what number does x have to be to make my denominator a 0? Well, since there's only an x, it has to be a 0. Okay, one of the things you can do is just take your denominator and set it equal to 0. Take both denominators. And since x equals 0, it's not like a 0-step equation. That's what's going to make that denominator 0. So our domain restriction is what x cannot be. And x can't be a 0 in this case, so that'll be our restriction there. So it can be any number but that 0. All right, so now into solving it, we need to find the LCM. So we have x's, we have a 4, so the LCM here is going to be a 4x. All right, and then we're going to simply multiply the entire numerator by that 4x. So we're going to multiply 4x to this 5 times 4x to the 7, and then times 4x to the negative 9. All right, we're going to simplify. X's will cancel out. 4's will cancel out here, and this x will cancel out with that x. All right, so that's what we have left over. 4 times 5 is 20. Okay, 7 times x is plus 7x. And then negative 9 times 4 is negative 36. All right, so just some algebra here. Let's go ahead and subtract 20 from both sides. It cancels out, we get 7x, and we get a negative 56. And then we will divide 7x by 7. And then we're going to get x equal to negative 8. And that'll be our solution. So if we check, our negative 8 does not equal our domain restriction. We're good to go here. All right, C, it's a little more complicated. All right, so first we have variables in our denominator. Let's start off by seeing if anything factors. And of course, we always want to check to see if there's things that factor before we do anything. So this denominator is going to be a GCF of 2. So factor out the GCF, we get x plus 4. All right. And this x plus 4 here, just kind of remember it's together. All right, so what is the domain restriction? Well, let's look at 1 over x plus 4. If we have x plus 4, what number does x need to be to make that entire denominator a 0? Well, what's the opposite of a positive 4? It'd be a negative 4. Negative 4 plus 4 makes that denominator 0. Another thing you could do is you can take the x plus 4, set it equal to 0, and then just simply solve for it. Subtract 4 both sides. We get x equals to negative 4. And this will work for the other denominator as well. 2 times x plus 4. Alright, set that equal to 0. Okay, divide both sides by 2. Alright, we get x plus 4, and then 0 over 2 is still 0. So it ends up being the same thing. Subtract 4 both sides. Right, and we get x equal to negative 4 as well. So the domain restriction here is x cannot equal negative 4. Okay, so slightly different denominators, but it ended up being the same number to this equation. So let's go ahead and do the LCM. So we got 2 times x plus 4. So we have an x plus 4, but we also need a 2. So it'll be x plus 4 here. 2 times x plus 4. And we're going to multiply each numerator by 2 times x plus 4. So we're going to have 2 times x plus 4 here, times that, times 2 times x plus 4 here, and times 2 times x plus 4 there. All right, then we're going to simplify. So it looks kind of confusing at first, but if you simplify, 2's cancel out, x plus 4's cancel out, we're really left with that 5x. X plus 4's here cancel out, we're left with that 2 times 1, then nothing cancels out on the right. So if we just clean this up, what do we have here? We have 5x left, minus a 2, so a negative 1, 2. So if you kind of change and make that negative, kind of won't mess up those negatives there. All right, and then 1 times 2x plus 4 is just 2 times 2x plus 4. Okay, so let's clean this up a bit. Let's distribute this 2 into the binomial behind it. All right, so we're going to end up with 5x minus 2 equals 2x plus 8. All right, then let's go ahead and get our variables on one side. I'm going to go ahead and subtract 2x both sides. All right, so that cancels. I get 3x minus 2 equals 8. All right, and then taking that 3x minus 2 equals 8, I'm going to add 2 to both sides. All right, so we get 3x equals 10. All right, then divide the 3. And we get x equals 10 thirds. All right, so there's that solution there. All right, so here's D, our last example. This one is a more complicated one. So again, look at our denominators, y plus 3, y minus 3. So if you look at those, negative 3, positive 3, factor this out here. It's the difference of squares, so x plus 3 times x minus 3. All right, so it's pretty clear the LCM is going to be x plus 3, x minus 3. Okay, that has every element of all the denominators there. Domain restriction, okay, x cannot equal negative 3 and 3. All right, so I've been saying x, but these are all y's. Let's change those. Y plus 3, y minus 3. There we go. Okay, there we go. Now our variables are straight. Okay, so those are the only two denominators that we really have. So if we, again, like we just set it equal to 0, right? Solve for y equals negative 3. Got y minus 3 equals 0. Solve for y here. That's going to equal positive 3. Okay, so we're going to multiply the numerators by this LCM. All right, so look a little messy at first, but we're going to multiply by y plus 3, y minus 3, multiply this one by it, y plus 3 times y minus 3, and then this 2 by it, y plus 3 times y minus 3. All right, and then we're just going to simplify here. So y plus 3 cancels that y plus 3, y minus 3 cancels that y minus 3. Both of these cancel all of that. All right, so let's regroup and see what we got here. So we got 1 times y minus 3. All right, equals 7 times y plus 3 minus 2 times nothing else. It canceled out. All right, so pretty straightforward. So let's distribute this 7 here. So we're going to get y minus 3. We don't need that parentheses anymore. We get 7y plus 21 minus 2. All right, let's see here. Let's combine like terms. So we get y minus 3 equals 7y. 21 minus 3 gives us 19. All right, and then let's get our variables together. So I have 7y on the right, y on the left. So I'm gonna subtract this y both sides. Keep my y's positive. So negative 3 equals 6y plus 19. All right, let's deal with this 19. Subtract 19 both sides. All right, so I cancel that out. 19 minus 3 is a negative 22. And we got 6y here. Then divide the 6. So just some algebra. And then we get negative 22 over 6. And that's going to reduce to a negative 11 over 3. And there's our answer here.